Welcome to the Explainer. Today, we're going to pop the digital hood of your car and take a look at the secret language that lets everything from your radio to your engine talk to each other seamlessly.
So let's start with something you've probably wondered about. When you throw your car into reverse, how does the camera instantly tell your screen what's behind you? Or how does a sensor in your engine trigger that warning light on your dash in a split second? Well, it all comes down to one thing: communication. See, the thing about a modern car is that it's not really one machine anymore. It's actually a network, a complex web of dozens, sometimes even hundreds, of tiny specialized computers. We call them electronic control units, or as everyone calls them, ECUs. Think of each of these ECUs as a total specialist. You've got one for the engine, one for the windows, another for the AC, you name it. For the car to work as one piece, all these specialists need to be talking to each other, constantly. And for that to happen, they have to speak the same language. Well, that common language is a protocol built just for cars, and it's called SUM/IP. So, okay, let's dive in and see what makes it tick. All right, its full name is a bit of a mouthful: Scalable Service-Oriented Middleware over IP. But it actually gives us a huge clue about what it does. The magic word here is service-oriented. It means one ECU can offer a service, like say reading the outside temperature, that any other ECU on the network can just ask for and use. And that's the thing. SUM/IP was designed from the ground up just for this job. It's incredibly resource efficient, so it can run on the smallest computers, but it's also super scalable, so it can handle the most complex systems in a high-end car. It's the perfect tool for a super demanding environment. Okay, so what does one of these messages actually look like when it's zipping around your car's network? The best way to think about it is like a highly organized digital postcard, where every single piece of information has its own specific designated spot. Every single message starts with this right here, the SUM/IP header. This is the envelope for our digital postcard. It's got all the critical info the network needs to figure out what the message is, where it needs to go, and exactly how to handle it. All right, first step in that header is the message ID. You can think of this as both the to address and the subject line all rolled into one. It tells you the service ID, like you're sending it to the climate control department, and the method ID, which is the subject, like, hey, set the temp to 21 degrees. Then you've got the length field, and this is absolutely crucial. It tells the ECU that's receiving the message the exact size of the entire package. That way, it knows precisely where one message ends and the next one begins. No confusion, no crossed wires. And then we have the request ID. This is basically its own little tracking number. When an ECU sends out a request, it gets a unique ID. The answer that comes back has that exact same ID, so the ECU can handle tons of different conversations at once without getting all its messages mixed up. Okay, but how do you get real-world stuff, like a specific temperature reading or your current speed, into this neat digital postcard? Well, that process has a name. It's called serialization. Serialization is for real, like packing a suitcase for a trip. You take all your items, your numbers, your data, and you convert them into a long stream of bytes. And it all has to follow a super strict set of rules so that when it gets to its destination, it can be unpacked perfectly every time. So SUM/IP has this rule book for how to pack all the basic data items. Whether it's a simple true-false or different sizes of numbers, there's a specific format. This makes sure that any ECU, no matter who built it, reads the data the exact same way. It's a universal standard inside the car. Okay, now this is where it gets really, really clever. For computers to work as fast as possible, data sometimes needs to start at a very specific spot in memory. So to make that happen, SUM/IP will sometimes add tiny empty spaces. Think of it like digital packing foam, just to make sure the next piece of important data lines up perfectly. Super efficient. All right, let's zoom out from all the technical bits and bytes for a second. We've seen how it works, but why does any of this matter to you when you're just trying to get from A to B? Well, here's the deal. These different message types are what make your car's features actually work. You press the window button, that's a request response message. A warning light pops up, that's a fire and forget command. It doesn't need a reply. And those parking sensors constantly updating the screen, that's a notification. SUM/IP is the backbone that handles all of these different kinds of conversations instantly. And this right here is what makes SUM/IP so incredibly powerful. Its scalability means the exact same language can run a simple door lock and the car's most advanced central computer.
For car makers, that is a total game changer. It means they can reuse code, saving a ton of time and money, and creating this one unified brain for the whole vehicle.
So that brings us to one last big thought. As our cars get more and more connected, and eventually fully autonomous, the sheer number and complexity of these internal conversations is just going to explode. The future of self-driving cars will be built on the foundation of protocols just like SEMIP, making a future possible with a level of smarts in our cars that, honestly, we're just starting to scratch the surface of.